The hole in the circuit conductor prongs of 15 and 20 ampere, 125-volt cord cap serves a specific purpose. It is designed to facilitate the removal of the plug from a receptacle, particularly in situations where grasping the plug by hand is difficult. This feature enables the user to insert a nail or other pointed object into the hole, providing leverage and aiding in the extraction of the plug. This design element is not mandated by the National Electrical Code, but it has become a prevalent practice among manufacturers of these types of cord caps. The presence of this hole does not impact the electrical performance or safety of the plug. It is purely a mechanical feature intended to enhance user convenience. It's important to understand that the dimensions and placement of this hole are not standardized. The size and location may vary slightly between different manufacturers and models of cord caps. However, the fundamental purpose remains consistent across all designs, which is to provide a means of assisting with plug removal when necessary. From an engineering perspective, the inclusion of this hole introduces a stress concentration point in the prong. However, the materials used and the manufacturing processes employed are carefully selected to ensure that the prong maintains adequate mechanical strength and durability, even with the presence of the hole. The hole does not compromise the prong's ability to withstand the stresses associated with normal use, such as insertion, removal, and bending. When considering the electrical safety aspects, the hole in the prong has no direct impact on the plug's ability to provide a safe and reliable electrical connection. The prong's primary function is to establish electrical contact with the receptacle contacts, and the presence of the hole does not interfere with this function. The materials used in the prong are chosen for their electrical conductivity and corrosion resistance, ensuring that the electrical connection remains secure and reliable over time. Furthermore, the design of the plug and receptacle interface is such that the electrical contacts are shielded from accidental contact, minimizing the risk of electric shock. The hole in the prong does not alter these safety features. It is worth noting that the use of a nail or other pointed object to remove a plug should be done with caution. Ensure that the object is insulated and that you are not in contact with any grounded surfaces while performing this task. This will minimize the risk of electric shock. While the hole in the prong is a helpful feature, it is not a substitute for proper plug maintenance. Regularly inspect your plugs and receptacles for signs of damage, such as cracks, loose connections, or corrosion. Replace any damaged components immediately to ensure electrical safety. In addition to the hole in the prong, some cord caps may also feature other design elements intended to improve user convenience. These may include textured surfaces for enhanced grip, ergonomic shapes for comfortable handling, or color-coded markings for easy identification. These features are all aimed at making the plug easier to use and more convenient for the user. The evolution of cord cap designs has been driven by a combination of factors, including safety considerations, performance requirements, and user needs. Manufacturers continuously strive to improve the design of these components to enhance their reliability, durability, and ease of use. The inclusion of the hole in the prong is just one example of how manufacturers have responded to user feedback and incorporated practical features into their designs. The National Electrical Code plays a vital role in ensuring the safety of electrical installations. The code sets forth minimum standards for the design, installation, and maintenance of electrical systems, including cord caps and receptacles. While the code does not specifically require the inclusion of a hole in the prong, it does address other aspects of cord cap design, such as materials, construction, and electrical ratings. These requirements are intended to prevent electrical hazards, such as electric shock, fire, and equipment damage. It is essential to comply with the NEC when installing or modifying electrical systems. This will help to ensure the safety of yourself and others. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. They can also help you to ensure that your electrical system complies with the NEC. The design and manufacture of cord caps involves a complex interplay of engineering principles, materials science, and manufacturing processes. The goal is to create a component that is safe, reliable, and easy to use. The hole in the prong is just one small example of the many design considerations that go into creating a high-quality cord cap. The selection of materials for cord caps is crucial to their performance and longevity. The prongs are typically made of brass or copper, which are excellent conductors of electricity and resistant to corrosion. The body of the cord cap is usually made of plastic or rubber, which provides insulation and protection from physical damage. The materials must be carefully selected to ensure that they can withstand the stresses associated with normal use, such as temperature changes, humidity, and mechanical forces. The manufacturing process for cord caps involves a variety of techniques, including molding, stamping, and assembly. Prongs are typically stamped from sheets of metal, and the body of the cord cap is molded from plastic or rubber. The components are then assembled using automated equipment. The manufacturing process must be carefully controlled to ensure that the cord caps meet the required specifications. Quality control is an essential aspect of cord cap manufacturing. Manufacturers employ a variety of testing procedures to ensure that their products meet the required standards. These tests may include electrical testing, mechanical testing, and environmental testing. The electrical testing verifies that the cord caps can conduct electricity safely and reliably. The mechanical testing verifies that the cord caps can withstand the stresses associated with normal use. The environmental testing verifies that the cord caps can withstand exposure to extreme temperatures, humidity, and other environmental conditions. The evolution of cord cap technology has been driven by a number of factors, including the increasing demand for electricity, the development of new materials, and the advancement of manufacturing techniques. Early cord caps were simple devices made of wood or ceramic. Over time, these materials were replaced by more durable and reliable materials, such as plastic and rubber. The design of cord caps has also evolved to meet the changing needs of consumers. Modern cord caps are available in a wide variety of shapes, sizes, and configurations. They may also include features such as surge protection, overload protection, and tamper resistance. The future of cord cap technology is likely to be driven by the development of new materials and manufacturing techniques. Researchers are exploring the use of new materials, such as nanocomposites, to create cord caps that are stronger, lighter, and more durable. They are also developing new manufacturing techniques, such as 3D printing, to create cord caps that are more complex and customized. The ongoing innovation in cord cap technology will continue to improve the safety, reliability, and convenience of electrical products. When selecting a cord cap, it is important to consider the following factors: the voltage and amperage rating of the cord cap, the type of equipment that will be connected to the cord cap, the environmental conditions in which the cord cap will be used, and any special features that may be required. The voltage and amperage rating of the cord cap must be compatible with the voltage and amperage requirements of the equipment that will be connected to it. The type of equipment that will be connected to the cord cap will determine the type of cord cap that is required. For example, a cord cap that is used to connect a lamp will be different from a cord cap that is used to connect a power tool. The environmental conditions in which the cord cap will be used will affect the choice of materials. For example, a cord cap that is used outdoors will need to be made of materials that are resistant to moisture and ultraviolet radiation. Special features may be required for certain applications. For example, a cord cap that is used in a hospital may need to be tamper resistant. By carefully considering these factors, you can select a cord cap that is safe, reliable, and appropriate for your needs. Remember that if you are unsure, consult a qualified electrician. They can help you determine the correct type of cord cap for your application and ensure that it is installed safely. Electrical safety is paramount, and taking the necessary precautions can prevent accidents and injuries. The seemingly simple hole in a cord cap prong represents a thoughtful design element aimed at improving user experience.